All right, hello. Welcome back to the 7.5 lesson. This is the continuation. It says more examples on the following pages. Let's take a look. Solve the equation by cross multiplying. Remember, when we have a fraction equals a fraction, you can find the cross products, and then our new equation is no longer containing fractions. Here we go. Okay, 3 times x minus 7 must equal 2 times 5x. Simplify and start solving. X equals -3. All right, try the next one. Okay, we got the x's all on the right side, so we want to isolate the variable, undo addition with subtraction. Undo multiplication with division. X equals -1/3. All right, try the next one. Simplify both sides before you start solving. Distributive property. 2x times x, 2x squared, x times 5, 5x. Take a look at what we've got. We have x's and we have an x squared. This is a quadratic equation. An equation with degree 2 with a variable squared is quadratic if that's the highest exponent. So we want to write this equation in standard form and then decide if we are going to solve using factoring or quadratic formula. There are other ways to solve quadratics as well, but those are our two main go-to methods for solving quadratics, is factoring or quadratic formula. All right, let's get everything on one side, 0 on the other. We need standard form. So I want a 0 on this side. I subtract 11x on this side, I've got to subtract 11x on this side. We still need a 0. There we go. There's the 0. Okay, we need to solve this. We have it in standard form. Notice that all 3 of these numbers are divisible by 2. Whatever I do to one side, as long as I do it to the other, it's allowed. It's okay. So if we divide these by 2, now we have x squared minus 3x minus 4. Well, that's easier to work with. What are 2 numbers that multiply to be negative 4 and add to be negative 3? And those go here. Negative 4 and positive 1. Those multiply to be negative 4 and add to be negative 3. So this is the factored form. Write each one of your factors equal to 0. And solve, and we get x equals 4 and negative 1. Make sure they don't make your denominator 0. They don't. We could check them completely, but I checked my answers. They are correct. Always want to make sure they at least don't make the denominator 0. So you'll have to throw them out if they do. All right, that's solving using cross multiplying. 3 more examples for you. Solve the equation, check your solution. These are the ones that in the examples in the main lesson, they had you multiply everything by the LCD. Well, I'm going to do this a little differently. I'm going to create a common denominator with all of the fractions in the problem. So for number 4, I want to create a denominator that's a 5x. So multiplying these denominators together, that's what I want. I want all of them to have a 5x as a denominator. So to accomplish that, I have to multiply this fraction by 5 over 5. So that's a 5x. 15 times 5 is 75. And I have to multiply this fraction by x over x. Now that's a 5x on the bottom and a 4x on the top. Do not simplify it. Don't cancel. We're making it this way on purpose. And this one, to be a 5x, I have to multiply by 5 over 5. So that's 35 over 5x. So now we have these 2 fractions can be added. Now take a good look at what I just wrote. If this numerator over 5x is equal to this numerator over 5x, then these 2 numerators must be equal to each other. So this must be true. 75 plus 4x must be the same as 35. It must be equal to 35. Now, if that bothers you, another way you could think about it now is to multiply both sides of the equation by 5x, and then these cancel out. And we get 75 plus 4x equals 35. All right, finish solving. On your mark, get set, go. x equals -10. All right, so you have some choices. As long as whenever you're multiplying a fraction by something, you're multiplying it by a form of the number 1, you're allowed to do that. Another thing, when we are dealing with equations, whatever you do to the left side of the equal sign, as long as you also do it on the right side of the equal sign, you can do that. All right, so number 5, do we want to multiply everything by the LCD, or do we want to get a common denominator on both sides and then just let the denominators go? Your choice. I'm going to do it like I did this one. So I'm going to multiply this first fraction by 2x over 2x. I'm going to multiply this second fraction by, okay, the denominator I'm trying to get is a 2x times an x plus 1. All right, so I multiplied the first fraction by 2x over 2x. I'm multiplying the second fraction. Notice I'm multiplying by a form of the number 1. So that doesn't have to be the same on the left and right side because I'm just multiplying by 1, multiplying by 1, multiplying by 1. Doesn't change the value of the numbers. Two x times 3x is 6x squared minus 5 times x plus 1. Okay, that's that side of the equal sign. Then over here we have 3 times x plus 1. Now we have a fraction equals a fraction. We don't want to do cross products though. We have a numerator over 2x times x plus 1, and we have a different numerator over 2x plus x plus 1. And the equation tells us that the two sides are equal. So, just like we did over here, if we know that's true, we know the numerators must be equal to each other. So that means that 6x squared minus 5x plus 1 must equal 3x plus 3 for this equation to be true. And our job is to find the value of the variable that makes the equation true. It has an x squared, so it's quadratic. Get everything on one side, 0 on the other. Factor and solve. On your mark, get set, go. Pause your video. I'm going to magically fill it in. So pause it here. Give it a try. See if you can come up with your answers for x. All right, here's the answer to number 5. We get x equals 2 and x equals -2/3. So when we had our quadratic equation, 6x squared minus 5x minus 5, I did not distribute correctly. -5 times x plus 1 is -5x minus 5. So if you had that part copied along with me and you had a 1 there like I did before, I'm sorry, you have to back up and try that again. Or just skip to the next one. But the important thing I want you to see is here we had 3x squared minus 4x minus 4. When we have a number other than 1 attached to the x squared, we factor by grouping. We rewrite the middle term using two numbers that multiply to be the product of the first and last one. So multiplies to equal -12 and adds to be -4. So I rewrote that as -6x plus 2x, then took out the GCF of the first two and the last two. We get that common factor of x minus 2 that's being multiplied by 3x and 2. Write each factor equal to 0 and solve. All right, if you want to try number 6, give it a shot and I'll fill in the work. Pause your video because soon the answer will magically appear. I am going to do this one a little differently though. I'm going to multiply everything by the LCD, which x squared minus 1 factored is x plus 1, x minus 1, so that will be the LCD for this fraction and this fraction. So that is what everything is going to get multiplied by. Give it a try. Pause your video and then unpause to check your answer. right, here's the answer to number 6. 5 and -2. Make sure it doesn't make your denominator 0. Those both work. Here's 7 and 8. Copy them down, pause your video, work them out, give it a try. I'm going to multiply everything by the LCD to eliminate my fractions as quickly as possible. Pause your video here. I am pausing mine right now, and then I'll start recording again when I have my answers written out. All right, here's number 7. X squared minus 4 factors into x plus 2, x minus 2, which is also helps us out with the denominators we had over here. So that's our common denominator that I multiplied everything by. So this canceled this out. So it's just a 9x squared on this side. Over here, you had to do your two fractions separately, get it in standard form, factor it, finish solving. All right, try number 8. All right, here's number 8. Very much like number 7. Pause here if you need to write these down. Hopefully you're just checking your answer. And number 9, one more, find the inverse. Consider the function 1 over x minus 2. Determine whether the inverse is a function, then find the inverse. So write down the function using a y instead of an f of x. To make the inverse, switch x and y, and solve for y. All right, so we got to get the y out of the denominator, so multiply both sides by y. We want the y by itself, so now divide both sides by x plus 2. And we have our inverse. Now it says determine whether the inverse of f is a function, then find its inverse. This is a 1 over x with a transformation. It's a hyperbola. Hyperbolas are functions, and their inverses are functions. So this is a function, and so is this. So we would need to say yes. Determine the inverse of f is a function. Yes, it is. And then we found it. Switch x and y, solve for y. All right, that's it. You have the answers, you have additional examples. Work on your 7.5 Big Ideas assignment. This is the last section of notes for Chapter 7. Big Ideas Math, Algebra 2. Thanks for watching. Have a great day. Remember to ask questions or review your notes as needed. Take care. See you soon.